In an abandoned industrial building somewhere in Europe, a rusted iron door still opens into a room that feels impossibly small. The brick walls are blackened. The ceiling is stained with decades of smoke. Massive steel pipes disappear into darkness overhead. And in the center sits the mouth of a furnace, cold now, silent, dead. But there was a time when this room was one of the most important places in the industrial world. Because before electricity-powered cities, before oil fueled global transportation, before automated systems controlled industrial production, entire economies depended on men whose job was to feed fire. Not metaphorically, literally, for 12 hours at a time, sometimes longer. A furnace stoker stood in front of temperatures hot enough to melt metal, shoveling coal, opening furnace doors, managing combustion, keeping boilers alive. If he stopped, the factory stopped. If he made a mistake, machinery worth millions in modern currency could fail. If pressure rose too high, hundreds of workers could die. Today, the furnace itself often receives the attention. The giant boiler, the steam engine, the steelworks, the factory, the machinery that built the industrial age. But the machine was never the entire story. Because every industrial furnace had an appetite, and that appetite was measured in human labor. The Industrial Revolution created a world powered by heat. Heat created steam. Steam created motion. Motion created production. Production created modern civilization. But someone had to stand between the fire and the machine. Someone had to keep feeding the system. And those people lived in conditions that often resembled industrial warfare more than ordinary employment. Extreme heat, coal dust, burns, exhaustion, explosions, toxic gases, shifts that stretched through the night, while entire cities slept. The modern world remembers the engines. History remembers the inventors. But millions of workers experienced the Industrial Revolution from a different perspective. Not from the boardroom, not from the locomotive, not from the factory floor, but from directly in front of the fire. And without them, much of the industrial world simply would not have functioned. The question is not how the furnace worked. The question is why entire industrial societies became dependent on a system that consumed enormous amounts of fuel, labor, and human endurance simply to keep moving. Because hidden behind every great steam engine was another machine, a human machine, and few workers stood closer to the heart of industrial civilization than the men who spent their lives feeding the fire. Welcome to History Forged. This channel explores the rise of industry, the evolution of engineering, and the people who worked inside the world's most powerful machines. If that sounds interesting, subscribe and join us for more industrial history and engineering documentaries. Long before the furnace stoker became one of the defining workers of the industrial age, civilization faced a problem that seemed impossible to solve. Human societies needed energy, not wealth, not machines, not factories. Energy. Everything else depended on it. A city could not grow without fuel. A mine could not operate without power. A factory could not produce without motion. And motion always required energy from somewhere. For most of human history, the answer was painfully simple. Human muscles, animal muscles, wind, water, wood. Civilization advanced within the limits of these resources. A mill could grind grain, but only if a river flowed nearby. A sailing ship could cross an ocean, but only if the wind cooperated. A horse could pull a wagon, but only until exhaustion forced it to stop. Every society was ultimately constrained by nature. Nature determined speed. Nature determined scale. Nature determined production. Then population began growing. Cities expanded. Trade increased. Empires demanded more resources. The old energy system started reaching its limits. The problem became especially visible in Britain during the 17th and 18th centuries. Forests were shrinking. Wood was becoming more expensive. Industries consumed fuel faster than traditional systems could supply it. Iron production required heat. Mining required power. Urban populations required warmth. The demand for energy was rising faster than existing resources could provide. Civilization was becoming energy hungry. And hunger creates pressure. The deeper problem was not simply fuel, it was continuity. Industrial processes could not function if energy arrived only when rivers flowed strongly or winds blew favorably. Manufacturers needed something predictable, reliable, controllable, a source of power that could operate day and night, regardless of weather. That search led underground. Coal had existed for millions of years beneath the earth. People had burned it for centuries. But now, coal was becoming something much larger than a fuel. It was becoming the foundation of a new industrial system. Coal contained extraordinary amounts of stored energy, more concentrated than wood, more abundant in industrial regions, capable of generating immense heat, and heat was becoming the key to everything. Because heat could create steam. Steam could create motion. Motion could power machinery. Suddenly, energy no longer needed to come directly from rivers or animals. Energy could be manufactured, controlled, expanded. This was the breakthrough that changed history. But it immediately created another problem. Steam engines were hungry, very hungry. The early industrial world discovered that mechanical power came at a cost. Massive amounts of fuel. Factories burned coal continuously. Mines burned coal continuously. Railways burned coal continuously. Ironworks burned coal continuously. Entire cities began consuming fuel on a scale previous generations could barely imagine. The Industrial Revolution is often remembered as a story of machinery. But machinery was only the visible layer. Beneath it existed a vast energy network. Coal mines extracted fuel. Railways transported fuel. Warehouses stored fuel. Factories consumed fuel. Every machine depended on this hidden system. And at the center of that system stood the furnace. The furnace transformed coal into usable industrial energy. Without furnaces, steam engines were useless. Without steam, machinery stood still. Without machinery, industrial production collapsed. The furnace became the beating heart of industrial civilization. But unlike the steam engine, the furnace could not fully automate itself. Coal had to be moved. Coal had to be loaded. Combustion had to be managed. Heat had to remain consistent. Ash had to be removed. Pressure had to be monitored. Someone needed to stand beside the fire. Someone needed to keep the heart beating. That someone became the furnace stoker. At first glance, the job sounded simple. Feed coal into a furnace. Keep the fire alive. But industrial reality was rarely simple. A steam boiler powering a factory was not a household fireplace. It was an industrial organism, a living system of heat, pressure, metal, water, and risk. Too little fuel and production slowed. Too much fuel and efficiency dropped. Poor combustion wasted money. Poor pressure control could create catastrophe. The stoker became an essential part of the industrial machine, not because he possessed extraordinary social status, but because industrial systems could not function without him. This created a strange contradiction. The Industrial Revolution celebrated inventors, engineers, and entrepreneurs. Their names entered history books. Their achievements became symbols of progress. Meanwhile, the workers who physically sustained those systems often disappeared from public memory. The stoker was one of them, invisible when everything worked, critical when something failed. And as factories expanded across Europe and North America, demand for these workers exploded. Every new boiler required fuel. Every new factory required heat. Every new steam engine required fire. The industrial world had solved its energy problem. But in doing so, it created an entirely new labor system. A system built around feeding machines that never wanted to stop. A system where human endurance became part of the energy equation itself, and as industrial production accelerated, the furnace room became something more than a workplace. It became one of the harshest environments in the modern world. Because keeping the fire alive was only the beginning. The real challenge was surviving beside it. The furnace stoker did not emerge because factory owners wanted to create a new profession. He emerged because industrial civilization had trapped itself inside a growing dependency. The more steam engines succeeded, the more fuel they consumed. The more factories expanded, the more heat they required. The more industry grew, the more workers were needed to sustain the fires that powered it. This was one of the hidden feedback loops of the Industrial Revolution. Machines reduced certain forms of labor, but they created entirely new forms of labor elsewhere. The steam engine is often portrayed as a machine that replaced human effort. In reality, it relocated human effort. The work did not disappear. It moved into mines, into rail yards, into boiler rooms, into furnace chambers, into the lives of workers who fed industrial systems every hour of every day. As steam power spread through Britain in the late 18th and 19th centuries, industrial demand expanded at an astonishing pace. Factories multiplied, textile mills grew larger, ironworks expanded, mining operations became deeper, railway networks stretched across entire nations. Every new industrial system required energy, and energy meant combustion. The numbers were staggering. Large industrial boilers could consume tons of coal during a single shift. Major factories operated multiple boilers simultaneously. Steelworks consumed even greater quantities. Railway depots, steamships, power stations, and manufacturing plants all demanded fuel. Coal became the blood of industrial civilization. The furnace became its heart. And stokers became the people responsible for keeping that heart alive. At first, much of the work remained brutally simple. Coal arrived by wagon, railcar, or barge. Workers unloaded it manually. It was moved into storage yards, then transferred to boiler houses, then shoveled directly into furnaces. Every step required labor. Industrial growth depended on thousands of repetitive physical actions. The modern observer often imagines industrialization as automation, but much of 19th century industry was powered by workers performing exhausting manual tasks beside increasingly sophisticated machines. This contradiction existed everywhere. Factories contained advanced engineering, yet many essential operations still relied on muscle. The stoker stood at the center of this contradiction. His work connected the old world to the new one. The coal shovel belonged to an ancient tradition of manual labor. The boiler it fed belonged to the future. As industrial systems expanded, boiler technology improved. Engineers developed larger and more efficient designs. Pressure systems became more sophisticated. Steam generation increased. Factories demanded greater output. But every increase in boiler size created another challenge. More heat required more fuel. More fuel required more labor. The machine was becoming larger. The worker's burden was growing with it. Inside industrial districts, entire buildings were dedicated solely to generating steam. Boiler houses appeared behind factories. Power stations emerged beside industrial complexes. Steam plants operated continuously, night and day, week after week, year after year. The fire rarely went out, and because the fire rarely went out, the workers could rarely stop. Shift systems emerged. Day crews replaced night crews. One group of stokers handed responsibility to another. The furnace remained active while workers rotated around it. Industrial civilization had effectively created an artificial sun, a source of heat that burned continuously, regardless of season, weather, or time of day. But unlike the real sun, this one required constant feeding. The industrial world's hunger for coal reshaped entire economies. Mining expanded dramatically. Railway infrastructure grew around fuel transportation. Ports handled enormous quantities of coal shipments. Cities developed around energy production. An interconnected system emerged. The miner extracted the fuel. The railway transported it. The stoker burned it. The steam engine converted it into motion. The factory transformed motion into products. Every worker depended on another. Every system depended on fuel. And every layer of industrial society ultimately depended on maintaining combustion. The furnace room became one of the critical links in this chain. Yet few outside it understood what happened there. Factory owners measured output. Engineers measured efficiency. Investors measured profits. But the daily reality inside the boiler house remained largely invisible. Visitors often remembered the heat first, then the noise, then the dust. Industrial reports discussed fuel consumption and boiler performance. They rarely discussed what it felt like to stand beside furnace doors for 12 hours, or what it meant to shovel coal repeatedly in temperatures that could become nearly unbearable. The expansion of industry created wealth on an unprecedented scale, but it also pushed workers into increasingly extreme environments. As boiler technology improved, pressure increased. As pressure increased, risks increased. The furnace was no longer merely producing heat, it was generating immense stored energy. Steam boilers became some of the most powerful machines of the 19th century, and when something went wrong, the consequences could be catastrophic. Explosions destroyed buildings, workers were killed instantly, entire factories could be damaged. The pursuit of greater industrial efficiency created new forms of danger, and the workers standing closest to the fire often faced those dangers first. By the late 19th century, the furnace stoker had become an essential figure in industrial society. He was not celebrated. He was rarely remembered. Yet entire cities depended on his labor. The lights in factories, the movement of machinery, the operation of industrial systems, all relied on fires that someone had to maintain. But as industrial civilization grew larger and more powerful, another question emerged. What was life actually like for the workers trapped inside these furnace rooms? Because feeding the fire was one thing, living beside it was something else entirely. To understand the life of a furnace stoker, it is necessary to forget almost everything modern industry has taught us. Forget climate control. Forget automated fuel systems. Forget electronic sensors. Forget computer monitoring. The 19th century furnace room was a place where industrial power depended directly on human endurance. The worker stood between the machine and failure was never far away. The furnace room existed for a single purpose: generate heat. Everything else was secondary. Comfort did not matter. Cleanliness did not matter. The worker's convenience did not matter. The fire mattered. The boiler mattered. Production mattered. A stoker's shift often began before sunrise, or continued long after sunset. Time became meaningless inside many boiler houses. The furnace created its own environment, its own weather, its own reality. The first sensation was usually heat, not ordinary warmth, not even the heat of a summer day. A relentless wave of thermal energy radiating from furnace doors, boiler surfaces, steam pipes, and combustion chambers. Workers described sweat-soaking clothing within minutes. Air became heavy. Breathing could feel like inhaling from an oven. Every physical movement required effort, and the work itself was intensely physical. Coal had to be shoveled continuously. A large industrial boiler could consume astonishing amounts of fuel. The stoker moved this fuel one load at a time, shovel after shovel, hour after hour, day after day. The task sounds repetitive, because it was, but repetition was precisely the point. Industrial systems depended on consistency. A furnace could not be fed randomly. The fire required balance. Too little fuel reduced steam production. Too much fuel reduced efficiency. Uneven distribution created hot spots and cold spots. Poor firing techniques wasted energy and increased costs. A skilled stoker learned to read the fire. The color of flames, the behavior of smoke, the sound of combustion, the condition of the furnace bed, the pressure gauges connected to the boiler. These observations became a language. The worker and the furnace entered into a constant conversation. The machine communicated through heat, flame, vibration, and pressure. The stoker responded with coal, airflow adjustments, and experience. This knowledge was rarely written down. It was learned through practice. A veteran stoker could sense problems before instruments revealed them. A change in flame color, a strange vibration, an unusual smell. Small details often carried important warnings. Because the furnace room was not merely uncomfortable, it was dangerous. Steam itself was invisible, yet it contained enormous power. Industrial boilers stored tremendous amounts of energy. When water became steam, pressure increased. As pressure increased, danger increased. The worker understood this reality every day. Behind the steel walls of the boiler existed forces capable of tearing buildings apart. Most days the system functioned normally, but industrial history contains countless examples of what happened when it did not. Boiler explosions became one of the great fears of the 19th century. A failed valve, poor maintenance, weak metal, operator error, any of these could trigger catastrophe. The result was often instantaneous. Walls collapsed, machinery shattered, workers died. The boiler house transformed from workplace to disaster zone in seconds. The stoker worked in the shadow of that possibility. Yet explosions were only one threat. Coal dust created another. Every shovel movement released particles into the air. The dust settled on clothing, entered lungs, covered machinery, coated walls. Many workers spent years breathing environments that slowly damaged their health. The danger accumulated invisibly. A dramatic explosion attracted attention. A damaged respiratory system often did not. Industrial society measured production carefully. The long-term health of workers received far less attention. The physical demands extended beyond heat and dust. Many stokers worked shifts lasting 10, 12, or even 14 hours depending on the industry and era. The furnace never slept. Therefore, someone always had to be present. Night shifts carried their own challenges. The body wanted rest. The boiler demanded labor. Workers fought fatigue while managing equipment capable of causing enormous harm if neglected. Exhaustion became part of the job. Entire communities adapted their lives around industrial schedules. Families adjusted to rotating shifts. Sleep patterns changed. Social life changed. The furnace influenced life even beyond the factory walls. What makes the stoker's story particularly revealing is that it exposes the hidden structure of industrial civilization. The public saw locomotives, factories, ships, steel mills. They saw the visible achievements. The furnace room revealed what made those achievements possible. Every spinning textile machine, every rolling steel mill, every steam locomotive, every industrial plant depended on controlled combustion. Someone had to create that combustion. Someone had to maintain it. Someone had to endure the conditions required to sustain it. The stoker became part of the machine itself, not officially, not mechanically, but functionally. The industrial system incorporated human labor into its operation. The worker was expected to provide strength, attention, judgment, and endurance. When the machine demanded more energy, the worker often had to provide more effort. The boundary between human and machine began to blur, and this may have been one of the Industrial Revolution's most important realities. The age of machines did not eliminate human labor. It consumed it differently. It reorganized it. It concentrated it around systems of enormous power. By the end of a shift, a stoker might leave, covered in soot, exhausted, dehydrated, and physically drained. But the furnace would still be burning. Another worker would arrive. Another shift would begin. The fire would continue. Because industrial civilization had become dependent on uninterrupted energy, and that dependency carried consequences that extended far beyond the boiler house. The true cost of keeping the fire alive was only beginning to reveal itself. The furnace consumed coal, but coal was not the only thing it consumed. It consumed bodies, time, health, families. Entire lives were gradually fed into the industrial system alongside the fuel. This was the hidden arithmetic of the Industrial Revolution. Factories measured coal by the ton. Owners measured production by output. Engineers measured efficiency through pressure, temperature, and fuel consumption. But nobody kept precise records of exhaustion. Nobody measured the years lost to damaged lungs. Nobody calculated the cost of standing beside extreme heat for decades. The machine's appetite extended beyond fuel, and the workers standing closest to the fire often paid the highest price. For the furnace stoker, danger was not a rare event. It was part of the environment. Every shift involved risks that modern workers would immediately recognize as unacceptable. Burns were common. A moment of distraction could result in serious injury. Furnace doors released intense heat when opened. Hot embers could be thrown outward unexpectedly. Metal tools became scorching to the touch. Steam leaks could cause severe injuries almost instantly. Workers learned to navigate these hazards because they had little choice. The danger was built into the job itself. Yet physical injury was only one layer of the problem. The deeper cost often accumulated slowly, year after year, shift after shift. Coal dust filled the air. Smoke lingered inside industrial spaces. Ventilation was frequently inadequate. Workers inhaled particles that settled deep inside their lungs. The consequences appeared gradually. Breathing became more difficult. Persistent coughing developed. Physical endurance declined. Many workers carried the effects long after they left the furnace room. Industrial society often viewed these outcomes as unfortunate realities rather than preventable failures. The system demanded production. The worker absorbed the consequences. The furnace room also accelerated physical aging. Extreme heat placed continuous strain on the body. Dehydration was common. Fatigue became normal. Recovery time was limited, because the next shift always arrived. A stoker might spend decades performing some of the most physically demanding labor in industrial society. The work left marks, not always visible scars, but changes in posture, changes in breathing, changes in strength, changes in health that accumulated over a lifetime. And behind every worker stood a family. The Industrial Revolution is often described through machines and factories, but its consequences were experienced inside homes. A worker injured in a boiler accident did not suffer alone. A family lost income. A spouse carried new responsibilities. Children faced uncertainty. Industrial risk extended far beyond factory walls. Entire communities became dependent on dangerous occupations. This dependency created a difficult reality. Workers understood the dangers. They lived with them every day. But they also needed wages. The furnace provided income. The furnace provided survival. The furnace provided the ability to feed a family. The industrial system offered opportunity and hardship simultaneously. Many workers accepted dangerous conditions because the alternatives were even worse. This was one of the most powerful forces sustaining industrial labor. Not ignorance, necessity. People rarely chose the furnace because they loved the work. They chose it because industrial society had created economic structures that made such labor essential. Entire neighborhoods grew around factories. Entire towns existed because industrial plants existed. Local economies became tied to the success of industries powered by steam. When production increased, communities benefited. When factories slowed, communities suffered. Workers became connected to the machine in ways that extended beyond employment. Their livelihoods depended upon its survival. This created a strange contradiction. The same system that endangered workers also supported them. The same furnace that damaged health also paid wages. The same industrial machine that consumed labor also created economic opportunity. Understanding industrial history requires understanding this contradiction. The story is not simply one of villains and victims. It is a story of systems. Systems that solved enormous problems while creating new ones. Systems that improved living standards for many while imposing severe costs on others. Systems that delivered progress but distributed sacrifice unevenly. The furnace stoker stood precisely where those contradictions became impossible to ignore. He experienced industrial civilization from the inside, not as an investor, not as an inventor, not as a politician, but as a worker whose body helped convert fuel into power. And as industrial production expanded, workers began questioning the price they were being asked to pay. Labor movements emerged across industrial societies. Workers demanded shorter hours, safer conditions, better compensation, greater recognition. The furnace room became one of many places where larger battles over labor rights were fought. Industrial employers often viewed labor as a production requirement. Workers increasingly demanded to be treated as human beings rather than replaceable components. This struggle would reshape modern industry. Safety standards improved. Boiler regulations expanded. Inspection systems developed. Engineering standards became more rigorous. Gradually, some of the dangers that defined earlier industrial workplaces were reduced. But these improvements did not appear automatically. They were purchased through decades of pressure, conflict, activism, and sacrifice. The modern workplace owes much to workers whose names rarely appear in history books, including the stokers who spent their lives beside the fire. Yet even as conditions improved, another transformation was approaching. A technological shift that would begin changing the entire energy system. New power sources were emerging. New machines were appearing, and the furnace that had once stood at the center of industrial civilization was slowly beginning to lose its position. The age of steam had conquered the world, but no industrial system remains dominant forever. And soon, the fire that built modern civilization would face a challenge of its own. The furnace stoker did not disappear because the work became easier. He disappeared because the world that required him began to change. For more than a century, steam had dominated industrial civilization. Factories depended on it. Railways depended on it. Ships depended on it. Entire cities depended on systems built around combustion, boilers, and human labor. The furnace room sat at the center of this industrial universe. But history rarely stands still. The same forces that created the steam age eventually began undermining it. Engineers continued searching for greater efficiency. Industrialists continued searching for lower costs. Societies continued searching for more reliable sources of power. And gradually, alternatives emerged. Electricity was one of the most important. Unlike steam power, electricity could be transmitted across distance. Power no longer needed to be generated inside every factory. Machines could receive energy from electrical systems rather than local boilers. Entire industrial layouts began changing. Boiler houses that had once been essential started becoming less important. The transformation happened slowly, then rapidly. Many factories adopted hybrid systems. Old steam equipment remained, while new electrical technologies appeared alongside it. For a time, both worlds existed together, the old industrial age and the new one. But the direction was becoming clear. Electric motors required fewer workers. Power distribution became more flexible. Industrial systems became easier to control. The furnace was no longer the only answer. Other developments accelerated the transition. Internal combustion engines spread through transportation. Oil increasingly challenged coal. New energy systems emerged. Automation expanded. Machines that once depended on constant human supervision became increasingly self-regulating. The industrial world still needed energy, but it needed fewer workers standing directly beside the fire. This shift altered entire communities. Many industrial towns had been built around coal, steam, and heavy manufacturing. Their identities were tied to the industries that sustained them. As technologies changed, some communities adapted successfully. Others struggled. The disappearance of the furnace stoker was not simply the disappearance of a job. It was part of a larger transformation, affecting millions of workers across industrial society. Skills that had once been essential became less valuable. New skills emerged. The industrial system evolved once again. But while the profession faded, its legacy remained everywhere. The furnace stoker helped power one of the greatest transformations in human history. The cities we live in today were shaped by the energy systems he maintained. The factories that produced modern goods depended on his labor. The railways that connected nations moved because workers kept steam pressure alive. The ships that crossed oceans depended on furnaces burning below deck. The Industrial Revolution is often told through machines: the steam engine, the locomotive, the factory, the great inventions. Yet inventions alone never changed the world. Systems changed the world, and systems require people. Behind every celebrated machine stood thousands of workers whose names rarely survived. The furnace stoker was one of them. His labor existed in a strange position within history. It was absolutely essential, yet largely invisible. When everything worked, nobody noticed him. People noticed the train arriving, the factory producing goods, the ship crossing the ocean, the steel mill operating at full capacity. Few noticed the worker sweating beside the furnace that made those achievements possible. This invisibility reveals something important about industrial civilization itself. Modern societies often celebrate outcomes. They celebrate innovation. They celebrate growth. They celebrate progress. But the labor sustaining those achievements frequently remains hidden. The furnace stoker reminds us that industrial systems are never purely mechanical. They are human systems. Every machine contains a human story somewhere inside it. Every technology rests upon forms of labor that are often overlooked. Every advance has costs that somebody pays. This is the lesson preserved within abandoned boiler houses and rusting industrial ruins. Walk through one today, and the silence feels almost unnatural. The furnace doors are cold. The gauges are frozen. The pipes no longer vibrate. The fire is gone. Yet the room still tells a story. Not simply about engineering, not simply about energy, but about dependence. For generations, entire civilizations depended upon controlled fire, and controlled fire depended upon workers willing to spend their lives managing it. The furnace room was one of the hidden engines of modernity. Its workers helped create unprecedented industrial growth. They helped build railways, factories, steelworks, ports, and cities. They helped power the world that followed. But they also reveal a deeper truth about the Industrial Revolution. The machine was never the whole story. The steam engine changed history. But the steam engine could not feed itself. The factory transformed civilization. But the factory could not fuel itself. The industrial system appeared mechanical from a distance. Up close, it was profoundly human. And perhaps that is the real legacy of the furnace stoker. Not the fire he maintained, not the coal he shoveled, not even the steam he helped create. His legacy is the reminder that every great industrial achievement rests upon people whose labor becomes invisible once the system succeeds. The modern world was built by machines, but those machines were kept alive by workers standing in the heat, breathing the dust, enduring the exhaustion, and feeding the fires that powered an age. And long after the flames died, their story remained buried within the foundations of the world they helped build.